In this video, we're going to talk about the PancakeFactory smart contract that is used by PancakeSwap to create token pairs. Let's get into reviewing the code. So you see that the contract is using the iPancakeFactory, which is an interface that contains all the required functions and events that the PancakeFactory must implement. The first line is a init code pair hash, which is of type bytes32, and it is a public constant. This is basically a hash. So you see that it's hashing with the Ketchak 256. It's hashing the bytecode of the pancake pair smart contract. After that, we have two public addresses, is the fee2 and the fee2 setter. The fee2 is the address where the fees will go, and the fee2 setter is the address that can modify this fee2 address. This mapping will store the token pairs, so you can specify the address of the token 0 and then specify the address of the token 1, and you will get the address of the pair. You can see here an example. So it's calling the get pair with the token 0, and then this token 0 can have many other token pairs. So you specify the address of the token 1, so you can get the address of the pair. Next, we have a simple address array that is storing all the token pairs, an event pair created that will specify the token 0, the token 1, the address of the pair, and the length of the all pairs array. The constructor is just setting the fee2 setter. This function all pairs length is returning the length of the all pairs array. Let's keep the create pair function for now. The next function is the set fee2, which will give an address. So the address where the fees will be sent. It will require that message sender is the fee2 setter. Otherwise, it will throw an error. And then it will set the fee2 address. And this function is setting the fee2 setter. So you see that we specify the address of the fee2 setter. It has a require here, and then it's setting up the fee2 setter. Let's get into the create pair function. This is the most important function because it's the one responsible to create the pairs. This function is external and it returns the address of the pair. The function takes in two arguments, the token A and the token B. So the tokens that we are providing as a user to create a liquidity pool. The require statement is checking that the token A is not equal with token B, because it doesn't make sense to create a liquidity pool where the tokens are the same. After that, it's trying to sort the tokens. You can see that it's checking that the token A is less than the token B, and if it is, then token 0 will be token A. If token A is not smaller than token B, then it means that token B is smaller than token A. So token 0 will be token B and token 1 will be token A. You can see that here we are comparing token addresses because the addresses are hexadecimal values, which means that they can be converted to numbers. So here we are comparing token A address with token B address. And this is simply looking to have the token 0 as the smaller address value. After that, we require that the token 0 is not equal with the address 0. After that, we require that the get pair of these two tokens is equal with the address 0. Because when we create a pair, we need to check if that pair already exists or not. And we only create the pair if the pair doesn't exist yet. This is what this is saying. Then we're looking to get the bytecode of the pancake pair smart contract by calling the creation code. We are looking also to generate a salt. So we are generating a salt by encoding the token 0 and token 1 arguments and then hashing it. So this is the code that is creating the pancake pair smart contract and it's adding it to the blockchain. Because when we create a pair, we create a pancake pair smart contract. And I will make sure to get into this contract as well and try to explain it to you guys. This is using the create to app code to create the pair. I will get into create to in the next video where I will explain it in a low level. Also, using create2, we can create a contract and know the address before it gets added to the blockchain. After creating the pair, we are calling the initialize function on the pair smart contract, and we are initializing the two token addresses. So this is like a constructor that is setting the tokens inside the pair smart contract. Then we are populating the mapping in both directions. So the pair of token 0 and token 1 will be equal with the address pair that we just created, and the pair of token 1 and token 0 will be equal to the same address because it has the same token addresses, but they are just in a different order. After that, we push the pair to the all pairs array and we emit the pair created event. You can see that this is the PancakeFactory smart contract, and if you go on contract to read contract, we have all the read functions. So we have the init code pair hash, which is the hash of the pancake pair smart contract bytecode. Then we have the all pairs array, which if we give it an index, it will retrieve an address array. Have the all pairs length, the length of the array. You can see that there are a lot of pairs. The fee2 address, the fee2 setter address, and then there is the get pair function, which takes in two token addresses and it will provide the pair address. Then on the write functions, we have three functions: the create pair, which takes in two token addresses, the set fee2 function, and the set fee2 setter function. Because in order to create a pair, I need to provide two token addresses and pay actual gas. I will use Tenderly, which is an awesome app that lets you simulate transactions on forked chains. I will make a video about Tenderly, but for now I will just show you guys the example of creating a pair using the PancakeFactory smart contract. So I will go in use custom contract, paste in the address of the PancakeFactory smart contract. I will say here that we want to use the Binance Smart Chain. I will click on use fetch contract ABI, and what this will do is give me the functions of the contract. I will say that I want to call the create pair function, and here I need to provide two token addresses. And because most of the tokens that exist are already on PancakeSwap, I will just create two random addresses and just give them as arguments here. So I pasted in some random addresses and now I will call the function. We see that the function status is success. The function called was create pair. The input was token A and token B, and the output is the address of the pair. Down here we can see the function trace, so which functions were called to create this pair. So the create pair function was called. We can go into the debugger here, and this has a really nice debugger that you can use. We can click on the button next to see what is the next function called inside this function, and the next call is the create to opcode, which will create the pair. After the pair is created, the next call is the initialize function from the pancake pair smart contract. And then the smart contract is created and initialized. I hope you guys understood the smart contract. It shouldn't be that complicated. The only complicated part is the part where assembly is used and where the create to opcode is used to actually create and deploy the pair smart contract. So I hope I explained everything that should be explained here. And in the next video, I'm going to dive deeper into create2 and how it works.